We're going to begin now our study of determinants of a matrix. And in general, the determinant of a matrix will tell us whether it's invertible or not. But a matrix is useful far beyond that. So some of you guys may have heard of something called Cramer's rule that allows us to solve a system of equations. That involves using the determinant. Other things as well is it has deep ties to geometry. Something you guys will study next semester is the matrix as a linear transformation, how it affects shapes in space. And the determinant tells you how it sort of affects the volume of that shape. Right, so it has really deep ties in lots of different areas. But for now, what we want to look at is just how do we compute the determinant. Right? So it's possible to write down kind of a formula for what a 2x2 and a 3x3 and a 4x4 and so on, the determinants are. That's not really a great way to think about them. The best way to do it is to think inductively about how to compute these determinants. So we'll start with the silly, simple example. But let's say we have a 1x1 matrix. Right? If it's just a 1x1 matrix, A, which is literally A11, okay, then the determinant is what we're defining here, which the notation we use is this det A. This is going to just be A11. Okay? So, that's something, just kind of a technical definition. But now let's actually sort of start defining this. Okay? So, if A is a 2x2 matrix, all right, then determinant of A, right? You can have the parentheses around it or not. It's kind of up to you. Another notation for the determinant is to put these bars, these sort of absolute value looking bars around it. Right? Another notation we have for determinants is we write the matrix itself inside some absolute value bar looking things. All right? And so these are just three different notations for this. All right, this last one's useful for when you're actually computing. All right. The way we compute this is we start out by doing this diagonal here, and we multiply the entries. So this is A11, A22. Okay. And then we subtract the opposite diagonal. Right, so then we go this way, and we multiply those. A12, A21. Right? This here is the determinant of a 2x2 matrix. Right, so let's see this with an actual example. Right, let's say A is 2, 3, -1, 8, let's say. Okay. Then the determinant of A, right, which, again, I'll write this notation just because I think it's useful for kind of bookkeeping. Right, so again, we're going to multiply these two together. So 2 times 8. And then we're going to multiply these two and subtract. So minus -1 times 3. Right? And that's 16 plus 3. So this matrix has a determinant of 19. All right. So how do we do this for a 3 by 3 matrix? Right? Well, for a 3 by 3 matrix, right, the way we do this is we have a few different options, actually, for how exactly we want to compute this. I'm going to start off with just one way of doing it. And actually, we've done this already with cross products. We did a 3 by 3 determinant to compute a cross product. So you should actually be a little bit familiar with this. So, right. So, det A, in this case, right, we're looking at the determinant of A11, A12, A13, A21, A22, A23, A31, A32, A33. All right. So, what we can do here is we're going to use what's called a first row expansion. All right. So we're going to start with this first row. And what we're going to do is imagine that we sort of get rid of this first row and this first column. All right. Let me just cancel this. All right. So we get rid of the first row and the first column. Okay. And then, so we write down where these lines cross, which is A11. And then we write down the matrix that's left over, because we're going to take the determinant of that. So this is A22, A23, A32, A33. All right, looks like we need a bit more room here. Okay. So, now that we've done that first one, we move on to the next one. All right, so we're still using the first row here, so actually I don't need to delete that one. Now, when we move to the second one here, the determinant's going to switch sign along the way in this computation. So it always starts with a plus up here in the top left, and then when we move to the next one, the sign changes. Right, so here it crosses at A12, but it's going to be minus A12 here. Like I said, it's going to switch. And then now we have a little 2 by 2 left again, so we write down that determinant. All right. So we've got that. Now let's do the last one. So we keep our first row crossed out, and then we cross out our third column. Now it went plus, minus, and now it's plus again. So we're going to add, we're going to add A1, I forgot the plus sign, add A13. Okay, so this is A21, A22, A31, A32. Right? And now we computed, we've expanded out the determinant of this 3 by 3 matrix into a combination of 2 by 2 matrices. All right. So these individual pieces here that we have, these individual pieces are what we call minors of a matrix. All right. So this right here, this one is what we'd call the 1-1 minor. It's the minor of A11. Okay. This right here is the minor of A12. And this right here is the minor of A13. Right? These minors are those matrices that are gone when you cross out the row and the column of that entry. Right? So like here, this is the 1-3 entry. Cross out row 1, column 3. What's left over is that minor. Right? And then we have these things called cofactors, which are when you add on these numbers and the signs that come with them. So A11, this one here is negative A12, and this is A13. These things here are what we call cofactors. All right, so let me write down that definition here. Actually, let's do an example of computing a 3x3 determinant, and we'll leave these definitions to the next video. All right. So let's do an example here. So if A is, I don't know, 1, 2, 0, 3, minus 1, 4, 0, 7, 0. Right. Let's say we have this is our matrix, then the determinant of A, right? And 1, 3, 0, 2, minus 1, 7, 0, 4, 0. Right. So again, I'm going to start out by crossing out the first row, and then we're going to start with the first column here. So we get 1 times the smaller determinant, minus 1, 4, 7, 0, right? And then, remember, it switches to a minus, and then it's this number, 2 times this determinant, 3, 4, 0, 0. Right? And then finally, we have our last one, which is plus 0, and then that small determinant, 3, minus 1, 0, and 7. All right? So, now we just compute out those small determinants. So we have, well, it's just 1 here, so we can leave off the 1. Negative 1 times 0 minus 7 times 4. And then negative 2 times this determinant, which is just going to be 0 minus 0. Well, all right, let's write out the steps there. 3 times 0 minus 4 times 0. Right, and then here, plus 0 times... It actually doesn't matter here, but we'll write it out anyway. 0 times negative 1. Alright, so this is, let's see, minus 28. This is all just 0, so minus 0, as is that. So more zeros. So it's negative 28. Right, so that's computing this determinant. Alright, so in the next video we'll talk about how to kind of expand this to more general determinants for larger matrices. And it turns out to just be an inductive process. We just keep using this same strategy over and over.